Okay, everyone, welcome. This is Jay, and I'm here to give you a brief tutorial on exponent expressions. And I just want to introduce them to you briefly here, how they work and what they mean, and also how the signs will make a difference when we work with exponent expressions. Okay, so think of how we might show using math when we're multiplying 5 together by itself 4 times. We might write 5 times 5 times 5 times 5 as it shows up here. Now, that would be a long, cumbersome way, especially if we maybe were multiplying together 20 times. So another way of showing it is using an exponent, and we can write it as 5 to the fourth power. So what you see in the second line here is exponential notation. And all it means is the 4 is what we call an exponent, and the 5 is what we call the base. So the base of 5 and the 4 being the exponent. And what this means is 5 is being multiplied together 4 times. So exponents and exponential notation is used to express the product of any expression, and it's used repeatedly as a factor. Let me show you a few examples of what I mean. Suppose we are not dealing with a number anymore, but a variable such as a letter b. And b is raised to an n power. N might mean can be any number. So n could be b being raised or multiplied together 10 times if n were 10, or 5 times if n were 5. We don't know it. It's just a general number. So to show a number b as a base raised to an exponent and being multiplied together n times, it would look like this. Now here's a couple examples I want to show you because of the difference it can make with parentheses. Suppose you have an exponential expression and it's -5 to the fourth power. Notice there are no parentheses in this expression. Using the order of operations, we always apply the exponent first. So the negative sign stays in front, and we multiply the 5 together 4 times. If you use your calculator, if you multiply 5 together 4 times, we get 625. However, there's a negative in front of the 5, so our answer has a negative 625. It has a negative in front of it. Here's another example, very similar, but it makes a big difference in the result. Here we have -5 in parentheses raised to the exponent of 4. So the parentheses make a difference because when we use the order of operations, now it means the exponent 4 applies not to just the 5 as it did in the previous example, but instead now it applies to the -5, the entire part of it. So what we do is we no longer leave the negative in front, but instead we multiply -5 together 4 times. And we can do that with our calculator, but remember, when we multiply two negatives, we get a positive. So multiplying this out, we end up with a positive 625 as our final answer. Let me show you one more quick example. Here's how we would evaluate an expression involving exponents. Suppose we had a -3 to the fourth power, all inside the parentheses, and then -4 inside the parentheses with a 2 outside as an exponent, and that's outside the parentheses. So to evaluate it, first we look at the first term, which is -3 raised to the fourth. So that would mean we leave the negative in front, follow the order of operations, and raise 3 to the fourth power. So multiply 3 together 4 times. When you do so, you will get 81, and there's a negative that's been left in front. So we have -81 for that part of the expression. Now think about the -4 in parentheses raised to the second power. Here's a little bit different procedure because the negative is now inside the parentheses and the exponent is out. So what it means is we're raising the entire -4 to the second power. So we have to multiply -4 together 2 times. When we do that, we get 16 because two negatives multiplied together gives us a positive. So we have 16. And then to get our final answer, we have to multiply -81 times 16. And we get our answer of -1296.